Okay, so there's my email address. If you have any questions, make sure you ask. Send me a message. Here's the homework for the week. Got 2 book assignments and a worksheet, which I'll show you later, and then a quiz, which I'll give you, and then give you the answers to it. Your grade cannot go down no matter what. If you do the majority of the work, turn it in whenever we get back, which might be next school year, I'll bump up your grade 1 letter grade, if I'm allowed to. All right. There could be a problem with equity or whatever, but if my boss or whoever says nothing, then I will do that. But I can't guarantee that there wouldn't be a problem with that. So, but your grade cannot go down. So the main reason why I'm doing this is so that you learn the material. I'm not as concerned about your grade, but I will bump it up if no one says I can't, if you do the majority of the work. 1 letter grade. Okay, let's get started. The first lesson is completing the square. We use completing the square to solve quadratic equations, just like factoring and quadratic formula. This is a third method, but when you use this method, you have to isolate the number by itself. That's the C value. Again, the quadratic formula is ax squared plus bx plus c equals 0. So when solving by factoring or solving by the quadratic equation, we get 0 by itself. But when we're completing the square, we need to get c to the other side. So let's do 3 examples here, where we are solve by completing the square. First one is x squared minus 6x minus 40 equals 0. So again, in order to complete the square, we need to get the c value to the other side. So we're going to add 40 to both sides. So we have x squared minus 6x equals 40. Keep it lined up. Need a space here because we're going to add a number to create that perfect square. Now, whatever number I add, I do need to add to the other side also. What that number is half of b squared. Again, the b value is the number in front of x. So in this problem, it's negative 6. So half of negative 6 is negative 3, and negative 3 squared is 9. So I'm going to add 9 to the left side to create a perfect square. And whatever I do to one side of the equation, I need to do to the other. Do a little arithmetic here. 40 plus 9 is 49. On the left side, we're going to create 2 parentheses, which will always be the same 2 terms when you complete the square. X and x will give us x squared. Since the last sign is positive and the middle sign is negative, these are both negative. Now we need to think what 2 numbers multiply give us 9 when combined give us negative 6. And that's negative 3 and negative 3. Like I said, these 2 binomials will always be the same when completing the square. So another way to get the x minus 3 is to square root the 9, or a better method is even to take half of the b value. Half of negative 6 is negative 3. And like I said, these 2 terms have to be the same, because in the next term you're going to write it as a binomial squared, thus the title, Completing the Square. Now we want to solve for x. So to cancel out a square, we're going to square root. Square root of 49 is 7. The square and the square root cancel out, but when you square root a square, you need absolute value. When you drop the absolute value, you put plus or minus on the other side. We can now solve this best by breaking it up into 2 equations. x minus 3 equals positive 7, and x minus 3 equals negative 7. We're going to add 3 to both sides, and the first answer is x equals 10. We add 3 to both sides in this equation, and we get x equals negative 4. And those are your two answers. When you have an x squared problem, you usually have two answers, but that's not always the case. All right, let's try another example. X squared plus 8x minus 11 equals 0. Again, we want to get the c value to the other side, so we're going to add 11 to both sides. Leave a space, because that's where your box is going to go, and we make a box on the other side. Again, that box is half of b squared. In this case, the b value is 8, so half of 8 is 4, and 4 squared is 16. So, sorry, this is a little sloppy. So we're putting 16 in both those boxes. That's a 16. We do the arithmetic. 11 and 16 is 27. Over here, we're going to make two parentheses like we did in the first problem, and they have to be the same exact term. X and x gives us x squared. Since the last sign is positive and the middle sign is positive, they're both positive. And now I can think, what two numbers multiply give me 16, added give me 8, or I could square root that 16, or I could take half of the b value. No matter which method I use, I'm getting 4 and 4. We rewrite it as a square, and now we solve for x. We square root to cancel out the square. It cancels out, and remember, when you square root a square, it goes in absolute value. Now, the square root of 27 is an irrational number. It doesn't work out even. The previous problem, it did work out even, so we had to show a lot of work to get to our answer. Over here, we're not going to show any work. I shouldn't say that. We're not going to show as much work, because when I drop the symbols and I put plus or minus on the other side, I can see that when I subtract the 4, I can't do that with a square root. So instead of breaking it up like we did in this problem, I can just subtract it, and really I'm done with the problem when I rewrite the answer. You can put the minus 4 in back or in front. It usually goes in front though, so I'm just going to squeeze it in there. So since I can't add negative 4 to a square root, I am done with the problem. This is two answers, because we are adding the square root and subtracting the square root. In a future chapter, we will talk about simplifying these square roots further, but for now, that's good enough. Let's try one more example. This one's a little bit harder because the a value is 2. Whenever you have a number in front of the x squared, you have to divide that out immediately. Now, if I'm going to divide that term by 2, I need to divide all the terms by 2, including the 0. You cannot complete the square unless the number in front of x squared is a 1. This creates a decimal here, which makes the problem a little harder. But now it's done the same way. We want to get that number to the other side, so we'll subtract 10.5. Now we need to create a perfect square, so we need to add some number to both sides to balance it out. Again, to get that number, we're going to take half of b squared. The b is the number in front of x, which in this case is a 6. So half of 6 is 3, and 3 squared is 9. So we're going to put 9 in both sides. Do the arithmetic on the left side, a little bit harder, might need a calculator, but that's negative 1.5. Over here on the left side, again, we create the two parentheses like the other problems, and they have to be the same term. X and x is the first term. Since the last sign is positive and the middle sign is positive, they're both positive. And now I can either square root the 9, take half of 6, or say what two numbers multiply give me 9, added give me 6. Anyway, it has to be 3 and 3. We rewrite that as a square. Now the next step is to square root both sides. Now when you square root a negative, the calculator will say there's no real solution or there's an error because you can't square root a negative. So most problems have two answers, but this is a problem that has no solution. All right, that's the first lesson. The second lesson, which I will title 9.6b, is simplifying rational expressions. Simplifying, let's see if I can spell rational expressions. So here we are not solving, so we're not going to get x equals. We're just trying to take an expression and write as little as possible while keeping an equivalent expression. So when they give you a fraction, I would say 95% of the time, if not 100% of the time in this class, something's going to cancel out. And they're giving you a big hint in one part of the fraction. You look at the smaller, the less complicated, the less stuff written down in the denominator, you see there's just an x plus 3. There's a very good chance there's probably going to be an x plus 3 at the top. So they're almost giving you a hint on what's going to cancel. So we look at the top and we're going to try to factor. So we have to figure out what can we pull out of both terms. They are both even, so they're both divisible by 2, but we want to find the biggest number. And the biggest number they're both divisible by is 4. When you pull something out, you make one parenthesis. And now how we figure out what's in that parenthesis is we need to divide both these terms by what we pulled out. Now it's a little sloppy to show work, but basically I want to divide both terms by 4. Over here the 4's cancel out, so I'm left with x. 12 divided by 4 is 3, and the plus sign comes along. To check this answer, I could distribute and see if I get back to the original problem, which I do. Now, like I said at the beginning, there's a good chance if we see x minus 3 at the bottom, we're going to see x plus 3 at the top, because these can cancel out. You can't cancel a binomial unless they are exactly the same, which these are. So they cancel out, and the answer is 4. Let's try another example. Here, the less complicated term is at the top, but it's basically the same problem as the other one. If there's an x minus 4 at the top, there's a good chance there's going to be an x minus 4 at the bottom. So we factor. There's nothing to do at the top. There's nothing to factor. But at the bottom, we can factor. We need to see what's the largest number I can pull out of there. Again, they're both even, so they're both divisible by 2. But the biggest number they're divisible by is 6. Again, we can use the top to help us with that, because something's going to cancel in this problem 95% of the time. If I pull something out, again, one parenthesis behind it, and then we're going to divide both these terms by the number we pulled out. 6's cancel out, the x comes down. The negative comes down, 24 divided by 6 is 4. So again, you can see we have x minus 4 at the top, x minus 4 at the bottom. They cancel out. Now the answer isn't 6, because if you notice, 6 is in the denominator. And the answer isn't blank over 6. When everything cancels out at the top, that's still got to be a number up there. And if you think about it, any number divided by itself is not 0, but it's actually 1. So it's 1 over 6. try another one. X squared minus 36 over x squared plus 3x minus 54. Now both terms are kind of complicated and they both need factoring. The top one is a difference of a perfect square. You can't pull anything out, so you make two parentheses. X and x will give us the x squared. Since the last sign is negative, they are opposites. Now I need to think, what two numbers multiply give me 36 when combined or when subtracted cancel each other out? That's got to be a positive 6 and a negative 6. Again, if you remember, if it's a difference of a perfect squares, they will always break down to two parentheses that are exactly the same except one is positive and one is negative. Now we factor the bottom. Again, can't pull anything out, so we're going to make two parentheses. Now remember what we said in the other problems. Same thing's going to occur here. Something's going to cancel out in this problem, so there's a good chance there's going to be a 6 at the bottom. All right, we have x and x to give us x squared. The last sign is negative, which means they are opposite. I need two numbers that multiply give me negative 54. When combined or subtracted give me 3. Now, again, my first guess should have something to do with the 6. So I need to think 6 times what gives me 54? 6 times 9 gives me 54. Now when I combine those, I need them to be a positive 3. For them to be a positive 3x, I need to make the 9 the positive value. So I'm going to put the 9 where the positive is and the 6 where the negative is. Now I can check by doing the outside and inside terms of FOIL, just to make sure my answer is correct. The outside terms give me negative 6x. The inside terms give me positive 9x. Negative 6x plus 9x is positive 3x. That needs to be my middle term, which it is. So this is correct. Now, just like all the other problems, something needs to cancel out. I see an x minus 6 and an x minus 6. They cancel out. What's left is x plus 6 over x plus 9. Now the x's do not cancel out, nor does the 6 over 9 reduce down to 2/3, because that's a binomial. You cannot cancel within a binomial or anything larger than that, unless the binomial is identical. So this problem is done. Last example. Here's one that is very difficult to factor. Anytime you have a number in front of x squared, that is hard to factor. Let me make that a little bigger. I have all this room here. Same problem. 6x squared plus 17x plus 10. All over. Now, if this was the only problem, this would be a much harder problem. Since they give us the bottom, that actually should help us when trying to figure out how to factor the top. So I would always do the easier one first. The bottom is much easier to factor than the top. You can't pull anything out of any of these terms, so we make two parentheses. Again, we have to have x and x to give us x squared. Since the last sign is positive and the middle sign is positive, these have to be the same. Now I need to think, what two numbers multiply give me 10, when added give me 7. I can always use that strategy as long as there is not a number in front of x squared. 5 times 2 is 10, 5 plus 2 is 7. It doesn't matter which one you write in the first and the second, but it's got to be a 5 and a 2. Now I will use that to help me factor out the top. Again, I can't pull anything out, so I'm going to make two parentheses. Now, I need two numbers that multiply give me 6x squared. So we can't just put x and x. We need something in front. X times x is x squared. I need it to be 6x squared. Now, if you remember what I said all year, when we're factoring, you usually want to pick the two closest together. All right, so when I think of what two numbers multiply give me 6, I think 3 and 2 and 6 and 1. And I have said that we should always guess the two closest together because they're usually correct about 80% of the time. But if you remember what we're talking about today, how things are going to cancel out, if you look at the bottom, these are both 1x. So in order for this to cancel out with something at the top, there's got to be a 1x at the top. So I should not guess 3 and 2 first. I should guess 6 and 1. So I'll put 6, and I can put a 1 there, but you don't need a 1. And again, the reason why I'm guessing that one first is because I'm thinking something's going to cancel out here. The last sign is positive and the middle sign is positive, so they're both positive. Now I need to think what two numbers multiply give me 10. Again, we have 10 and 1 and 5 and 2. Now, I can't do the same strategy I did for the bottom. What two numbers multiply give me this, added give me that. That only works when there's a 1 in front of the x squared. If there's any other number there, that strategy doesn't work. So we just really have to guess and check. Now, the reason why I should guess 5 and 2 first is not because they're necessarily the closest together. It's because I see 5 and 2 at the bottom, because something's going to cancel out. So I want to pick 5 and 2. And if you remember what I said back when we were in school, you never want to put a number where something could be pulled out. So, like, for instance, if I put the 2 there, I could pull a 2 out of both those terms. So I know that can't be the answer. So if the 2 can't go there, a better guess is to put the 2 there. Now this is still a guess, so I need to check the outside and inside terms to make sure it's correct. The outside terms give me 12x when multiplied. The inside terms give me 5x. When I add those together, that's 17x, which is what the middle term is. And like I said, something's going to cancel out. If you notice, we have x plus 2 in both the top and the bottom. So what's left is 6x plus 5 over x plus 5. Again, the 5's can't cancel out because these are binomials. Same with the x's. The x's can't cancel out because they're binomials. The only time you can cancel out binomials is when they are exactly the same. These are not exactly the same. So this problem is done. That's the lesson that's the second lesson of the chapter. The worksheet that goes with that is right here. So this would have been Tuesday's assignment. Now to go to Wednesday's assignment. (9.8). Now, if you notice, we skipped 9.7. We actually did 9.7 in school. Remember, I said we're going to do these out of order because I wanted to teach the quadratic formula first. So we're at 9.8. Cubic functions. Now, this material is not on the quiz that I will show in a little bit, but it would be on the chapter test. Again, remember, your grade can't go down. Doing the quiz and the test is for your benefit only. And like I said, I won't be grading it, but I will give you the answers to the quiz and the tests. All right, 9.8. We've talked about perfect squares and perfect cubes. Again, perfect squares is a number times itself. The answer is a perfect square. So 1 times 1 is 1. So 1 is a perfect square. 2 times 2 is 4. 4 is a perfect square. 3 times 3, 4 times 4, and this goes on forever. We also want to talk about what are called perfect cubes. That would be a number times itself times itself. We'll just list a couple of them. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Or 2 cubed is 8. Let's do one more. 3 cubed, which would be 3 times 3 times 3. Well, 3 times 3 is 9, and 9 times 3 is 27. So this also goes on forever, too. All right. Let's go to some examples. Solve for x. We have a rectangular prism. Actually, it's a perfect cube. What that means is all the sides are the same. 2x, 2x, and 2x. They give us the volume to be 512 centimeters cubed. And we want to find x, or solve for x. Well, a volume of a cube is basically side squared, or length times width times height. Either way, both formulas are good. It might be easier to use this formula, but I'll probably show both. 2x times 2x times 2x, or 2x cubed. So I'm doing both at the same time. Over on this one, 2 times 2 times 2 is 8. X times x times x is x cubed. Over here, we're going to distribute, or better yet, raise each of the powers to the power of 3. And we're multiplying the exponents. So that becomes 2 cubed and x cubed. And that's 8x cubed. Now, that's the volume that we plug into this equation. So instead of writing V equals 512, we're going to write 8x cubed equals 512. Now we're going to solve for x, so we're going to divide by 8. Calculator works pretty good here. That's going to be 64. Now, to cancel out a square root, to cancel out a square, we square root. To cancel out a cube, we actually do what is called cube root. So it's a little 3 inside the little check mark. And we do that to both sides. On this side, it cancels out. Now, there is no absolute value, because technically the rule is you have to go from an even to an odd. And we started with an odd exponent. But what you just need to remember is when you cancel out a cube, there is no absolute value. Now we want to find the cube root of 64. Basically, what number times itself is 64. We can do that on the graphing calculator. Cube root is math 4. Punch in the number, and the cube root of 64 is 4. So if we go up here, the next perfect cube is actually 64. So 64 is both a perfect cube and a perfect square, just like 1 is. And there are other numbers down the road too. Okay, next example. We want to determine whether it's a quadratic, a cubic, linear or exponential. So they're going to give us 3 tables. Three, 4, 5, 27, 64, 125. So I'm going to make these 4 tables as quickly as I can. And we want to match these tables with these 4 words up here. They all have 3, 4, 5 in common. That one is 7, 11, 15. Three, 4, 5, and on the other side we have 8, 16, and 32. And the last one, 3, 4, 5, 9, 16, 25. So we want to match these 3 tables. I'm sorry, these 4 tables with these 4 vocabulary words. I would do whatever you think is the easiest first. Since we are talking about cubics in this lesson, probably cubics would be the easiest one to do. So remember, a cube is any number times itself. So I would look to see which one of these, if we cube the x, do we get the y? So I'll start on this side. 3 times 3 times 3 is not 9. 3 times 3 times 3 is not 8. Nor is it 7. But 3 times 3 times 3 is 27. Now I want to check the other 2 to make sure they're right. 4 times 4 times 4 is 64. And 5 times 5 times 5 is 125. How I could check it on the calculator is I could go 5 times 5 times 5, or I could do 5 cubed, just to check to make sure it's 125. So this one is cubic. So that's how I would do this. Do the easiest one of these. We've been doing a lot of quadratics in this chapter, so that's just the square. 3 times 3 is not 7.